Hello, people of the internet. I wanted to remake this video. I made a version a couple years ago that probably could use an update. And in this video, you will learn how to use the C++ Visual Studio's debugger. I highly recommend any programmer out there using C++ to learn how to use the debugger. While cout statements are great, and I use them all the time, there are many other tools that we have in our arsenal, so we'll get into that. Now, in order to download Visual Studio Community Edition, that is free. You'll download the installer for that, and the only thing you need to download is just the desktop development environment in C++, and you will download that and install it. So I've already done that, and I already have a program for us to look at today. This is a bunch of sorting algorithms, and it just implements is an anagram, is a palindrome, just some practice kind of basic coding assignments. But that's not why we're here today. We want to be able to troubleshoot and debug our programs. So let's just run this. We go to the console, and this is our output. We see that we found some reverse strings, we found some palindromes, we found some anagrams, and that's all great stuff. And I want to introduce us to our first point, and that is the breakpoint. So when I ran this program, I'm just going to stop this here. I ran it by hitting play on the local Windows debugger. If I was to do Control F5, the program will just run, and it is done, and it is no longer executing, and it is complete, and I can close that by exiting out of the console. But if I just hit F5, I'll run the debugger, and I'll stop code execution at this breakpoint. But I don't want to just stop it at the very end. I'd like to stop it a little bit higher to see what's actually going on in the program. So I'm going to hit a breakpoint right here. I'm going to stop debugging and begin debugging. So here we are. We know that we're debugging in Visual Studio because we have now some different tools that are up and available. We have the diagnostics tools which are available, and then we see continue here as well as the debugger tools right here. So right now we're stopped at line 40 in execution because we put a breakpoint right there. But let's say that I know this for loop is doing exactly what I want it to, and I want to continue on down to this for loop. I hit continue, and it's still stopping at that breakpoint, so I'm going to disable that one. Then I hit continue, and now we go to the next breakpoint. And that's exactly how that works. Anywhere that you are worried about commands, not executing properly, or where there are issues, you could set up several breakpoints that will just continue. Okay, this didn't crash. Okay, now we're here. Let's try this. Continue. Okay, this didn't crash. And you can kind of just keep walking the breakpoints all the way until you get to the bottom of your function and just say, okay, nice. I made it to the very bottom of this function. Which brings me to the other tools, where we have step over. So if I hit step over, it literally goes to the next line in execution. But let's look at that maybe in a different way. So I just restarted debugging. We are at this point of the program. I'm going to hit the step over, and I literally just go line by line by line every single time I hit step over, which is really handy because maybe we want to check values. So this is where another part of the debugger can really come into play. So here we have, down here are our locals. We also have autos. And so these will, as you watch, turn red and blink, and things are changing. Here we have I, which is our counter. It is moving. Now it's 102. Things changed to these objects. And so you can really keep track of what's happening down here with your incrementers, just with all the different objects that are within scope. So as soon as we leave this function, we won't be able to look at what's happening to those variables. So we can only observe what's in scope. But it's also nice because if we hover our mouse over certain variables, we can actually get a whole bunch of information just by hovering over. We can see that the size is 6 at these indices. We have these ordered pair objects um, that are being pushed into this letter word. And now there are, yeah, like I said, 6 of them, and we can look exactly what's happening underneath the hood. Whereas, if you try to do this with cout statements, totally possible, but it could just get a little clunky. We're looking at, an ordered pair object, and it could just get real big real fast. So just by taking a peek makes it really nice and handy. Let's say I was really curious about what's happening with this specific object, and I didn't really want to keep track of it down here with the autos or the locals. I can right click it and I can actually add a watch. So now I'm looking at it here in my watches. So before I had autos, now I have watches, and I can pull up what's happening with this object in more detail. So now I'm going to keep going through and hit the step over button. Okay, it changed again. More things are being added to this object. Okay, it's incrementing in size. And you can really get a lot of information about what's exactly happening inside of the program by just stepping over things as opposed to using cout statements. Also, we have the step out command right here. So step out, right now I'm in a for loop, and I would like to step out of it. And I'd like to get down to that for loop. So I hit step out, and it literally just kept running until it got to this next breakpoint. So if I know that, okay, I'm done with that for loop, I'd like to step out of it. We hit the step out, so I'm going to hit that again, step out. And it stepped out of only this local for loop. I'm still in this greater for loop. So I'm going to disable the inner one, step out, and I'm all done executing these nested for loops. And all the while keeping track of what's happening in my autos with that object. So I'd like to also show another thing that you can do in the debugger. So I'm going to stop debugging. I'm now not running the program. I see I got my other menus back. Everything's good in the error list. I'm going to go ahead and debug again. And now let's look at a little bit of memory management. So you'll notice over here on the right hand side, we have this memory usage. Usually you'll probably see summary, but if we go over here to memory usage, you might have to click this little icon here, which just says enable heap profiling with snapshots. And what I'm going to do is take a snapshot. So at this moment in time, we're looking for a delta. So right now, this is our reference level of, we're at the top of this function here. We've instantiated, nothing that we're concerned about, but I'd like to start keeping track of objects that we're instantiating in memory. So I'm going to go ahead and hit continue, and we're now at line 60, and I want to take another snapshot. So it looks like we created 2 items in memory, which could be reasonable, could not be. That's up to you to tell, but at this point, okay, so we got 2 objects on the heap that have been allocated. All right, let's continue. We're now in this part, and I'm going to take another snapshot. So we didn't create any objects in between these 2 points. Outstanding. Let us go to the next point where we continue, and we take a snapshot. Okay, so still no more points have been put onto the heap. But what happens when we leave this function? We want to make sure that once we leave this local scope, that everything that we were working with also is destroyed. So we expect to see a deallocation of 2. So I'm going to do step over. So we've now left that function. I'm going to take another snapshot, and yes, we did in fact lose those 2 instantiated objects. So this is good memory management. We allocated 2 objects, we deleted 2 objects, and we don't have a leak. If we didn't see a down 2 here and the profile had at a number 2, 10, 100, every single time that function is called, and when we leave that function, we are now cutting into our RAM. So speaking of RAM, I want to bring up the last point of the debugger. So we're going to go in to our location. And what happens when we actually want to look at where this is in RAM? So one thing I'll note is that right now I stopped the debugger. I'm going to go to Debug, Windows, and I don't see much going on in here. But that will change. So let's go ahead and debug. I'm going to go to Debug, Windows. Ooh, bunch of stuff. So now that I'm actually running in the debugger, I have a bunch of stuff that I can look at. So what do I want to actually look at? Well, I want to look at memory. And I have 4 memory modules on my computer. So I take that back. These aren't 4 memory modules. These are 4 windows to where you could actually look at up to 4 places in RAM at a time. And so I'll pull up 2 just to kind of see what that looks like. So yeah, I have memory 1, memory 2. And these are, not memory sticks, but I can look at several places in memory at once. So let's do that. I'm going to grab this. I'm going to copy, paste. I'm going to hit enter, and unable to evaluate expression. Well, dang darn. I want to look at where it is in memory. And in order to do that, I need to know its address. So I use the AND operator. So I hit enter. Ah, there it is in memory. I see it. This is what it actually looks like in RAM in all of its crazy glory. But that's just the letters word object. I also want to look at the other one, letters word 2. So I go into my second RAM module, same thing, hit enter, and that's where that is in RAM. So I want to look at them both at the same time, let's say. This gets really handy, maybe not with these objects, but once you start messing around with pointers and you want to see like what exactly happened to your pointers, you can drop your pointer in here, which pointers are just addresses, and you can observe what's happening. So here we are, we see the letters word 1 object in RAM and the letters word 2 object in RAM, and let's step over. And like with our watches, autos, and locals, everything that's changing every single time we hit the step over, step over, step over, every single time we're doing that, we can see things changing in the RAM. What are these things? Actually, it depends on what your level of programming is and what you're trying to look at, but this could be very helpful. I really use this RAM observation, like I said, when working with pointers. But I hope that this is helpful for you all to find memory leaks, debug your programs, and step through things line by line, as well as observing the RAM. If there's anything else that you all would maybe like to know about Visual Studios, you can go ahead and leave those in the comments, but I hope this is helpful, and happy hunting for all of your bugs. Cheers.